Okay. Hello?
Hello, sir. Yes, we can hear you.
Okay. All right. Thank you. Okay, we will start now. I think, yep. Okay, this is our second, second or third. I think third. Okay, the third mechanism that we will cover. Okay, we have covered uh, uh, authentications. We have covered authorizations, and today is our third mechanism that we will learn. Okay, cryptography 101. Right, and I have changed uh, the sequence a bit. Okay, but I don't add any new slide. Okay, for this topic, you should know what is cryptography or encryptions or cipher. Okay, all of these are having the same meaning. Okay, what is encryptions? What is decryptions? What is key? And what is plain text? And what is the cybertext? Next, you should know what is stream cipher or block cipher, okay, and the transposition cipher and substitution cipher. Under substitution cipher, you should know what is monoalphabetic substitution cipher and polyalphabetic sub, substitution cipher. Okay, and what is a cryptanalysis? Okay, and for uh, symmetric encryption and uh, 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 symmetric encryption. Okay, that we will cover uh, next week. All right. So, what is a cryptography? Okay, cryptography in cryptography, we try to hide the meaning of that message. Means, okay, the entity is there, but the other person who is not unauthorized cannot comprehend that message. So it means the meaning of the message is hidden. All right. And we can do this via substitution and transposition. Okay. Substitutions, we will replace some letter with the other letter. Okay. Transposition, we will change the position of that letter. Okay, and this is the example of the substitution. This is the Kama Sutra, right? And this is what we call citate. Okay, all right. The terminology. Okay, we have these three actors, or yeah, we, uh, after we can call them actors. Okay, Caesar here, and he want to send message to his group, and this is asterisk obliques, the goal, the goal or goal, GAUL. Okay, now okay, Caesar want to send this attack message to his group without the goal knowing. All right. So what uh, 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 after Caesar has done, okay, it will apply the key to to scramble the words. Okay, in this process, it substitute actually, it substitute the initial word, okay, and transform it to the other words, okay, and this process we call it encryption or cipher, okay, all right, we change the uh, initial text to the new text. Okay, then when it received by his soldier, and they will need to use the key to change back from new text to initial text, and this process we call it decryptions or decipher. Okay, the initial text we call it plain text, PLAINTEXT, plain text, and the new text we call it ciphertext. Okay, so these are the terminology that you need to know. Okay, plain text, when we change to ciphertext using a key, we call it encryptions. When we convert it as ciphertext using the key back to plain text, we call it decryption. Okay, so the first technique is substitution cipher. This technique will replace the plain text letters or alphabet to the other alphabets. The result of this transformation we call after ciphertext, and the rule of the substitutions we call it key. Okay, and it to correspond to Shannon principle of confusion. We will discuss this detail after this slide. Okay, in encryption system, they need to apply two Shannon principles. One of them is confusions, and the other one is diffusion. All right, and this particular method still being used today. Right? The encryptions in Caesar shift cipher, we move 3 positions forward. Okay, A will be replaced with D. B will be replaced with E and so forth. Okay, and that's we call Caesar shift cipher. Okay, I have this. Okay, when I say Caesar shift cipher, the key will always 3. If the key is not 3, we call it shift cipher. All right, but there are some author prefer to maintain the term Caesar shift cipher. Okay, when the key is not 3. All right. Okay. If you have that kind of the question, you can ask me. Right. Okay. Decryptions. Okay. When we encrypt, we move forward 3 position. Then when we decrypt, we move backward, reversing the process. Okay, so ATTACK will be replaced with DWWDFN. All right. Okay, and this particular crypto algo, we call it mono-alphabetic cipher. Why mono? Because we use one single rule, one substitution rule. It's applied to every single alphabet. So because of that, we have about 25 keys. A until Z, okay, which is 26. Okay, why we need to minus 1? Because if we apply shift 0, means there are no transformation. All right, so we omit key equal to 0, we have 25 possible key. Right, that this is the algorithm. Okay, for encryption, we plus key size. In Caesar shift cipher, it should be 3. Okay, in shift cipher, it can be any keys between 1 to 25 without 3. Okay, the decryptions, we minus the key size. In this case, is 3. Right. So it's simple, right? It's quite straightforward, but during that time, this is secure. Why? Because there are no standard alphabet format. I believe at this time only Roman have it. So 3 does make sense. Okay. So what is cryptanalysis? Cryptanalysis is a study of cryptography algorithm. Okay. To recover the key. To recover the key. Having the key, any person who have the key, okay, is known as authorized person. Right? So we actually, the idea of cryptanalysis is to know what is the key so that we can know what is the plain text. if we destroy this crypto system, means we cannot know what is the rest of the message. So the focus is to discover the key. There are two methods: brute force attack. Brute force attack means we just apply uh, uh, the technique is we just try and error. Okay, since it have only 25 possible keys, 1 to 25, okay, it takes time, definitely. But when we use a computer system, that is very fast. Okay, and the other one is analytic attack. Okay, what is analytic attack? Okay, cyber attacks only. Okay, we know what is uh, after cyber attacks, and we do know the crypto algorithm that the system use, and we need to figure out what is the key. This cryptanalytic type we will use mostly in our course. Okay, known plain text. Okay, here we have the ability to access the crypto system. Okay, from we enter plain text. That's why it say known plain text, and we apply in that crypto system. It produce cyber text. Okay, and we use this knowledge to figure out what is the key. Okay, chosen text. Okay, this is either plain text or cyber text. Okay, and we will generate the cyber text or plain text. The main purpose, we want to know what is the key. Okay, in other book, they call it chosen plain text, where we know what is plain text and we can apply the crypto system and obtain cyber text. Then we will figure out what is the key. And the other one is chosen cyber text. Mean we have after cyber text and we do decryption to know what is plain text, to obtain what is plain text, and we use it to discover the key. It's quite straightforward, but you see here, all right? Oh, okay, all right. Why I put it over here? Because some author did mention chosen text attack, okay, and the other authors, okay, use chosen plain text or chosen cyber text attack. So I just want you to know that. Okay, this is what will happen when we apply brute force attack. Okay, we will do try and error, okay, to try any single key, 1 to 25. Okay. Right? So the lesson that we have learned is the key must be long. Okay, very large key. Okay, all right. So that the exhaustive key search will be ineffective. This is what we can do, okay, when we try and error. Okay, having only 3 tries or at most 25 tries, okay, we can know what is that message or plain text. Okay, now what's wrong with monoalphabetical cipher? We use same rule, one substitution rule. Therefore, okay, the frequency of alphabet in plain text will be similar or same with frequency of alphabet in up to cybertext. This is the essence of frequency analysis. Okay, instead of we apply exhaustive key search or brute force attack, okay, we can apply frequency analysis. It means that, okay, we can resolve the issue in shorter time. Okay, I will show you this when we have tutorial next week. Okay, all right. When we analyze a group of uh, cybertext, okay, alphabets, actually we have done block cipher or block encryptions. All right, block encryptions. Okay, when we use brute force attack, actually we apply stream cipher or stream encryptions. Block means what? We need to process a group of alphabet. Okay, stream cipher, it is one alphabet at a time. Okay, so the first one actually apply when we do frequency analysis because we need to know the frequency of the alphabet. That's why we need to apply block cipher. Okay, for brute force attack, we are looking at one character at a time. Okay, we apply stream cipher. Okay, how to resolve this? Okay, using same substitution rule for every alphabet, make it prone to frequency analysis attack. So how to sustain this attack? How to prevent this attack? By applying multiple substitution rule in our crypto algorithm. And this technique, we call it polyalphabetic cipher. because, okay, the rule, okay, will change a few times. Okay, there are two crypto algo that we will learn. Okay, under homophonic substitution cipher. Homophonic means what? Homo means single. Phonic means sound. Okay, here you see we will replace all the alphabet with a number, two-digit numbers. That's why we call it two-digit substitution cipher. Okay, now we have a 26 alphabet, but two digits mean 00 to 99, which mean 100 numbers. Okay, we divide by 4. Okay, we have 25 numbers. So that's why we need to combine two alphabets. It can be Y with Z, it can be V with W, it can be X with Y, and so forth. Right? So that we will have 00 to 25. Okay, for the first group. For the second group, we will have 26 to 50. Okay, and then the third group start with 51 to 75, and last group, okay, we will have 76 to 99. So it means that we have 4 substitution rules. So the first alphabet will use the first substitution rule. The second one will be used the second rule. Third, fourth will follow accordingly. All right. Next one is reverse frequency. All right. Before I forget. Okay. Applying this crypto algo, we will have what? We will have of the smaller graph. Can I have that one? Okay, here. This graph, okay, will be divided by 4. Every single substitution will be divided by 4 because we have 4 substitution rule. So if we want to apply frequency analysis, it's a bit difficult to do. All right. The next one is reverse frequency. Okay. Before I forget. Sorry. You see here. The key is what? THEK. So the first group will use T as 00. And then you will apply 01 until, 04. All right. The next group is, okay, you start with H here. All right. You will continue 26, 27 until 49. And the third group, you start with E. Okay. E will be 50. right, until 74, and last K, right? And then you continue with 76 until 99. So here you will continue at A. Okay, once you reach Z, Y or Z in this example, you will continue with A. These are the technique in two-digit substitution cipher. Okay, reverse frequency. All right, we create the same table first. Okay, two-digit, and then we transform it into this table. This table, okay, refer to the reverse frequency analysis graph. Yeah, see here? All right. So this will be transformed to this. All right. So now, if we apply this technique, reverse frequency substitution cipher, it will be 0600374345 and 16. However, okay, if you compare with this one, right, it's different. Okay, and I will show you in tutorial, okay, the way we will create or apply reverse to frequency substitution cipher without, okay, without after creating this table. Okay. All right. The third one is Virginia tableau or Virginia table. This is the table. Actually, if you look it carefully, it is a group of shift cipher. Here, T is 0 and below T is 25. All right. Now, what happened? Okay. Assume that this is for the key. This is for plain text. Okay. So in the middle is cybertext. Okay. You can change this to plain text and this with key. All right. It's still the same. Okay. However, you need to be careful. Always maintain your table. If you use this as a plain text, okay, when you decrypt, use this as a plain text. Okay, all right. Now, how to do encryption? You mesh your plain text with your key. This is the cross section, and this will be your ciphertext alphabet. Okay, to do decryption, okay, you look for your key here, okay, and then you to identify your cybertext alphabet. Okay, and you will know the plain text. It's quite straightforward. But this algorithm, okay, crypto algorithm is secure because it takes roughly 1 century to crack. Okay, all right. Okay, polyalphabetic cipher, one-time pad, OTP, not one-time passcode or one transaction PIN. Okay, it is the most secure crypto system, but hardly be used. Okay, why? Because it has issue of managing the key. The key must be random, and it only allowed to be used once. All right? Okay, so that why it being less being used or hardly used because of management and logistical effort and coordination on the key. Key must be random. Right? Okay, this is how we apply one-time pad. Okay, the number can be in sequence 00 until 25. Okay, you may ask me why we always start with 0. Okay, remember, we are computer scientists and 0 have some meaning, not valueless. Okay, it have some value. That's why we start with 0. Okay, so it can be in sequence 00 to 25, but sometimes it can be random. Okay, between 00 and 25. Okay, for encryptions, we will apply addition. Okay, and then we will apply modular 26. That is encryptions, decryptions, reverse it. Since we apply addition, we will to decrypt, we will apply subtraction. Okay, and then modulus 26. Why 26? We want to get the number between 00 to 25. Okay, right. This is more modern polyalphabetic, okay, mechanical cipher device. This is during American Civil War. This is during Second World War. Okay. The key is the sequence of this what we call it this. Okay. The key also here, all right, it have some this. Okay, it apply shift cipher from key equal to 0 until key equal to 25. Right? Okay, we will stop now. And we will continue at 10 after 11. If you have any question, you can ask me in a Telegram. Okay? Until 10 past 11, thank you.